Hello and welcome to the second session of the Recap 2020. It's my pleasure, Gregor Wolf, to introduce to you Dr. David Kunz. So David is a development specialist in Node.js for the Node.js runtime of the cloud application programming model. And he finished actually a PhD in theoretical particle physics. But then David followed his vocation, which I didn't know as a non-native speaker. It's Berufung in German, vocation. He followed his vocation for programming, and he's always striving to gain competitive knowledge for emerging technologies and advocates for superior paradigms and tools for efficient development. Okay, quite a long sentence. He is very active also in the CAP forums and in the OpenSCP course forums. And without further ado, I want to just hand over to David. Take it away now with service consumption, messaging, and eventing.
Yeah, thank you very much, Gregor. Let me share my screen. And please tell me if you can see it.
Unmute, yes, looks good.
Okay, perfect. So thank you, Gregor, for this nice introduction. I'm David, and in this talk, I will tell you a little bit about service consumption, messaging, and eventing in CAP applications. So actually, I only have one single slide, and that's this one. So typically, when you develop a CAP application, you start with a CDS model. And on this model, you build your CDS service. In 99% of the cases, you have some database where you store your data, and sometimes you also have a UI. Now, back in the old days, people would always build monoliths, and where everything is contained in one single application. But in this modern world, we always, or most of the cases, have a microservice architecture where you actually have multiple services which also need to communicate with each other. And this communication is the stuff of the demo I will show today. And there are basically two ways to communicate across services. One is via synchronous requests. In this case, for example, HTTP requests. It's called synchronous because you trigger the request and then you have to wait until you get the answer, and then you can continue processing whatever you want to do. Just a disclaimer, in Node.js, this is also asynchronous because of the event loop. Basically meaning when you send this HTTP request, the process does not block and other stuff gets processed while you wait. But semantically, from a business perspective, you shoot a request, wait for the response, and then continue processing. The other form of communication is asynchronous and in form of events. What typically happens is that you have this external service here, and this external service will send events to some message broker, man in the middle. In this demo, we will use the enterprise messaging service on SAP Cloud Platform. And the message will be safely stored in a queue. So if the receiving application should be down for whatever reason, the message is stored safely. And then the message will leave the queue and go into the service, and you will receive it and act accordingly. So the synchronous messaging, meaning fire and wait, and the other type of messaging is basically fire and forget, and the other one will react accordingly. So let's jump into code, because that's what the conference is all about. I will start with a simple bookshop application. It's nothing fancy. It's the typical bookshop, which you already saw today. And you don't need to know much about this application. Just keep in mind that we have a database entity called orders. In these orders, we have a field called status, and the status defaults to processing. And such an order can be completed, processing, or blocked. Okay, and that's basically everything you need to know about this app. Now, what we want to do is trigger synchronous requests. So in the slides, this arrow here. So what would we actually do if we want to achieve that? Now, the good thing about model-driven applications, like what CDS is, where we have a model, is that we define some kind of contract, right? If you know the model of your service, you know how your service looks like, what your service can do, which entities your service serves, and so on. So we know the shape of the service. We don't know the content. We don't know which data is stored in the databases, but we know what we can do. And the main idea is that we can make use of it when we trigger HTTP requests to external services. Because in the end, external OData services have this metadata file, which gives us an idea how that service looks like. So let's make use of it and jumpstart right in. So the first thing you should do if you want to consume some APIs is look for a system from which you actually want to consume these APIs. That's always the first step. And in this demo, I will use the SAP S/4HANA Cloud System. And there's this nice web page, api.sap.com, where all those APIs are listed, which you can consume. You can browse and search. In this case, I search for business partners. And there's an OData API business partner allowing to perform CRUD requests. So that's exactly what I want to do. So I click on it. Now I can inspect how the service looks like. And if I think that's a good fit, I can click on details and I can download the specification in EDMX format. That's basically the metadata file, which every OData service has. Okay. Now back to my application. I can just copy this file into my folder. And now to import it into my CDS workspace, so to say, I just write CDS import with the name of the file. As Daniel has shown, it's also possible to just run CDS watch and drag and drop that file, but I prefer the manual way here for you to see what's actually going on. And I imported it and it did two things. So first, it created, and you can see it due to the coloring of the Git status, it created a new folder called external in your service folder. And here the EDMX file is moved and the season file is created. So if you look at the EDMX file, that's kind of ugly. It's the typical EDMX file you see when you hit $metadata on your OData service. But the season file, first of all, looks better. And it is basically a CDS model. And you can import it in your own CDS models, which is quite cool. And the other thing it did in the package.json file is it created a new section in CDS requires. So that section basically tells our framework what services we need to have to make this application work. In this case, we say that we need this API business partner API, which is of kind OData with a model located to this newly moved or newly created season file. Okay, and without doing anything else, I can already start the server in CDS watch mode. And you can see that there's a hint, mocking API business partner at some path. So if I look at my server, you can see that not only my own service entities are served, which I defined myself, but also the whole external API. So without doing anything, I already have a mock system running alongside my app, which I can query and so on. And this is super neat because now I don't have to actually set up all those connection details to my SAP S/4HANA system, which can be quite tedious. I can just immediately start developing and querying that mock server. So that's quite awesome. Of course, if I look at some entities, I don't see any data because it's a mocked system. We only know the shape of the data, but we don't know the content of the data. And one entity which I'm mostly interested is this AS_business partner, the main entity, if you will. And also this doesn't have any data. So let's fix that by providing some mock data. Now CAP has a very easy possibility to create data just by providing some CSV file. So let's create a folder called data. And in this folder, I create a file called API_business_partner, which has the same name as the API, dash, and now the name of the entity for which I want to provide data. In this case, it's A_business_partner, and the ending is CSV. And here I can create some mock data. So let's just do this. I know that the key is business partner. I have a first name, I have a middle name, I have a last name, and I have a field called business partner is blocked. So let's just put Alice, and let's just open this file again, because I have this nice add-on which highlights the different colors, different columns in different colors. So I see if I do a mistake. So I have Alice in Wonderland, and she's not blocked. I have Bob, the builder. No, I also don't block him. And I have Chaba, the hut. And everybody knows that he's a criminal, so I block him. Now my server is always running in watch mode and will restart automatically whenever I do some changes. So if I hit refresh here, you can see that the data is already there. I have Alice in Wonderland, and all those fields which I did not provide are automatically set to null. So I have Alice, I have Bob, and I have Jabba. Okay, and you can see that this service entity is contains quite a lot of fields, and I don't need all of them. And so there will be possibilities to, I would say, massage the entity and select only a subset of those fields, which we will need for our purposes. So what we can do now is we can actually make use of the model in our own service, and also maybe expose such a service entity and delegate the request to our external system. So let's try this. I open my catservice.cds, and here I can just import my definition. Using from external. Normally I have code completion here. And at least here I have code completion, and I can see that I can import the API business partner service, and I can rename it to external or ext. And now I can treat it as any other CDS model. So for example, I can create my own read-only entity, which I call business partner, which is a projection on this external entity, A_business partner. And you can see I immediately get code completion. So if I do that now, then my own service entity business partner is served, which has all the fields of A_business partner. But I don't only want to do that, I just want a subset of fields, and I want to do some renaming. So I take the key business partner, again code completion, and I want to rename it as ID. Then I want the first name, the middle name, and the last name, as well as this business partner is blocked field. So after I did that, I now have to tell my service that whenever a request comes in to business partner, I want to delegate the request to my external system, or in this case, my mocked external system. I can do that by going to the catalog service j&s, my handler implementation, and just delegate the request by using a normal onHandler. So first, I want to make this function asynchronous to make use of the await keyword. From my own service entities, I just import my business partner service entity, which I just defined. Then I can connect to my API, which is defined in package JSON. So I simply write const external service equals to await CDS connect to, and now the name of the API. And now I can make use of it. So this thingy here is kind of a hook, a window to the external service where I can use various operations on it. And then the only thing left to do is to register an on handler. And whenever there will be a read request to business partner, I take the request, and now here I have to program the logic to delegate the request. Now comes the coolest thing about this approach. You all know the core query notation, which you can write in our core query language, and we can use this core query notation to actually formulate requests, which are then interpreted correctly and sent to this external system. So if you write select from foo and execute it against this external system, it will actually be translated into an OData request, just an HTTP GET request of foo, and the result will be returned. So you only need to know one query language to talk to your database as well as your OData service. And that's quite awesome. So in this case, we can just delegate it completely. So we take our external service, we write tx-rec. So this stands for transaction, but it's not a database transaction because it's an external service. And it's always a bad idea to have inter-service transactions. That never turns out good. Think of this as coupling your request to your run command. So we have information when we run some query, we have information about the request. Then we can also allow something like principal propagation and stuff like that. So we run a command, and I can here create any select statement I want, or I can just take the original query, which is in the request property. And that's all I need to do. So let's save the file, go back to our service. And you can see that we have here now this new service entity business partner, which we created. If I press on it, you can see the data. And it's the massage data. So instead of the key business partner, I have the key ID, as well as all those all those fields which I selected in my projection. And obviously I get the mock data because I delegated my request to this mocked external system, and which provides me the data. And we also support query parameters, not all of them currently, but many of them. For example, I can just say top equals to 1. Then the corresponding HTTP request which we would send would also contain top equals to 1, and so on and so forth. Now, this is all good for mock systems, and you can do quite a lot of stuff. You can program against it for development until your APIs are finished. But in the end, you want to connect to a real system, to the real system from which you want to consume the API. So for this, you need to do a little bit of plumbing. You need to create a destination on SAP Cloud Platform. You need to create an Access UA instance, and both services you have to bind to your application and create a destination to this API endpoint. It's a little bit tedious. I'm not going to show you that. But once you've done that, once you bound your app to those services and you stole the environmental variables from your Cloud Foundry environment and stored it in this default env.json file to mimic the environmental variables from Cloud Foundry after the binding is complete, then you can just go to the package.json file and just say that, that you have credentials for this API, and you say that the destination should be the name of the destination which you configured. So in my case, it's API slash 098, I think. Don't remember. Let me grab it real quick. Sorry, cat. So it's cap API 098. Okay, so let's go back to watch mode. Now, if I refresh this page, the data from the real SAP S/4HANA system should be served. You can see the request takes a little longer, and you can see the data. And this comes from the real SAP S/4HANA systems. system just by providing this destination, which is quite cool. And again, I can say top 1. I can also say filter equals to first name equals to Alice. And you can see there's also Alice in this external system. Okay. So if I go back to the slides, you now just saw how we used an actual HTTP request to an external system. And it doesn't even feel like an HTTP request because you could use the core query notation to formulate your requests. Later, I will show you a little bit more. And if you want to learn even more about core query notation and how to formulate queries, I recommend watching the talk by Vitaly later, who will also show later the core query notation and how to formulate these. Now let's concentrate on this asynchronous part, where the external service actually emits events to some enterprise messaging system, coming then back to our own service. So that's also quite easy to do. So first, let's switch off this credentials block here by renaming that stuff. And now we are back into mocking mode, where we mock our external system. Now, to consume events, we first have to teach our external system to actually emit events. Otherwise, there's nothing to consume. But CDS, again, has some nice way to do that. So in our external folder, where our API is, we can create a new file with the same name as the service, but with a JS ending. And if we do this, we can just export a function which takes the service as an argument. And here we can just implement some custom handlers. Exactly the same mechanism you're used to when you develop a normal CAP application. So we can just write service on, and we can say whenever there's an update on a_business partner, we want to take the request and emit an event. Now to emit an event, we first need to construct the payload of the event, the data which you want to send along. So let's do this. And here you need to have the same scheme as the event payload, which would be sent by SAP S/4HANA Cloud. And that's a little bit mysterious, but the format is the following. So you have an object which has a key field, which is an array. Inside the array, there's one entry, which is an object, which has the business partner field, key field, and the content of this is the business partner ID, which in this case, we can just extract from our request. So don't ask me why this form is so complicated, but well, it is what it is. And once we have the payload, we have to emit an event, and it's super easy to do that. You just write service.emit. Now give the name of the topic, or to be more precise, the ending of the topic. In this case, it's business partner / changed, and provide the payload. And that's basically it. Now we teach our service to actually emit events. And because I always do mistakes, I also want to log it to see that everything is going well. So let's create a request.http file, which Daniel already showed you. That's a nice possibility to send HTTP requests. So let's just send a patch request to our business partner. So just copy the URL. And the type should be JSON. And I want to set, I want to patch Alice. And I want to set the field business partner is blocked to true. Now let's see what happens. Let's open the console. I send the request. And you can see that the data is not correct. Business, because I'm missing an S. Now let's do that again. And you can see now we sent an event with a correct payload, that Alice was changed. That's, by the way, how SAP S/4HANA sends events. It will not include all the information, like which fields have changed or something like that. It will only tell you that this particular business partner has changed. It will not tell you how it was changed. Okay, so now our fake system sends events. Now we can come back to our main task to actually consume events. So we didn't need to configure any system, nothing at all. We can just concentrate on developing and be fast. So the only thing which we need to do is go to our service implementation again, catalog service j&s, and you may have guessed it, to react to events, we need to register some handlers. So we have this external service, basically our view to this external system, and we can just register a handler on it, and we can say X service, whenever there's the event business partner changed, we want to do something. So we can register a handler which would get the message, and then we can implement our custom logic. So in this case, we want to log it again. Business partner changed. And the payload of this message is in the data property. And you can see already that this message object is very similar to the request object, which we would get if we would, normally register some handlers. And the data is again stored in data, and it actually behaves very, very much like the request object. And in the new architecture, which Daniel briefly mentioned, it will actually be pretty much the same object. So now that we receive the event, we can do some business logic, and I thought of a nice example. So in our service, we have orders with a certain status, and the main idea is that we wait until some business partner is changed. Then we will look if this business partner was blocked, because for some reason we can cancel all the outgoing transactions. And if the business partner is blocked, we want to set the status of all our current orders which are in processing to blocked. Okay, so that's the main idea. And let's start it. So the first thing which we should do is to look in our own database if we have orders for that particular business partner. So currently we only know the ID. The ID is stored in message.data, if you remember, .key, the first element, .business partner. So let's see if we have orders. For this, we can create a transaction by writing cxtx and couple it with our message. So when we do that and the message processing is completed, then the transaction will be automatically committed. Doesn't matter much here because we are just triggering some select requests, but later we also want to modify the database, and then it's quite handy. So once we have the transaction, we can just retrieve our own orders. And let me just make this function asynchronous so I can make use of the await keyword. So I just take the transaction and I want to run a query on it. In this case, I want to select from my orders table, and I only want to select the ID. And by the way, there's also a new syntax to select columns. You can just write it like this. And I have also a where clause. I want to say I am only interested in the ones with status processing, as well as the created by field equal to my business partner. Okay. Now, it could be that I don't have orders for that business partner, so let me check that. And if I don't have anything, I want to return. And the main idea is always return as fast as possible. Don't do unnecessary processing. don't trigger any external services if you don't really need it. Don't trigger your database if you don't really need it. And just be sparse. So if I didn't find any orders, I don't want to do anything. Otherwise, I need more information about the business partner. So currently I know, okay, I got business partner Alice, for example. I have an order from Alice, but I don't know if Alice is blocked. So we need to now query the external system to get more information. Now let's do this. I take my external system, again, couple it with the message. And now I can run a query which I formulate using this query language. I can say, okay, select from business partner. And I want only the field business partner is blocked, where the ID field is my business partner. And it's the ID field, not the business partner field, because it's the massaged entity I created. Now, if I didn't find any business partner, or if the business, and I only want to select one, or if my business partner is blocked field is equal to false, I don't want to do anything, because then it's still a valid business partner and I don't have to do anything. Otherwise, I now need to update my orders. So I take my orders and I want to process this in a promise all fashion, because the order of these requests doesn't really matter. And I map each of those order to a database statement. So I take my transaction and I run update orders for that order, and I want to set the status to blocked. Okay. And if everything is fine, I want to console.log it that I blocked my orders. Okay, so because I'm always doing mistakes, let me try that out. I again trigger this HTTP request to my mocked external system. And probably I did some mistake because Alice should be blocked. Let's check my coding. Let's do some console logs. Let's see. Here. This should be Alice in uppercase letters, because that's the key of the business partner. Okay, now it works. So you can see I received the event business partner changed of Alice. I found orders because in my local database I have an order for Alice. And then I changed the orders and set the status to blocked. And then I get this console log that I blocked my orders. So everything works. Now, sometimes it's not enough to just update your local database, because it could be that you need to inform all your consumers that something happens, right? So let's do that. And we can inform other consumers of our application by just emitting an event. So in our service definition, we can now say, okay, we want to emit events. And the name of the event is order blocked. And the payload of the event is just the UUID of the order. Now in our handler implementation, we can now emit events by just looping over all orders and emitting this event. Now, how do we emit an event? We take our service and write emit, give the name of the event, and provide the payload, which is in our case the order. And we also want to console log that we emitted this event. Now let's send that request again. And you can see that now we emitted the event order blocked with the ID of the order. And if there would be more orders for Alice, then we would emit also more messages. Now that's all fine for this mocked external system, but in the end, again, we want to connect to the real system. So we go to our package.json file, and we want to now enable enterprise messaging. To do so, I create this credential section again, and I want to set the prefix property to SAP/S for HANA on demand /C098/BO. This is the prefix of the topic. So if you configure your SAP S/4HANA Cloud System to send events, then all those events are prefixed with a certain topic, and that you need to provide here. And the other thing I want to do is create this messaging section where I say that I want to have enterprise messaging enabled. So I save the file. Now what it does under the hood is whenever you do something like this, where you write external service.on, when you listen to events, it will automatically create a queue, this thingy here, in the enterprise messaging instance. And in this queue, or this queue will then listen to exactly that topic. So next time this external system would send an event, it will go into that queue and later on reach us. So let's see if that worked. Let me go to the real SAP S/4HANA system. And I have here my business partner Alice. And I can set the status of Alice to central block. That field corresponds to this business partner is blocked field. I save it. Changes have been saved in this external system. I go back to my application, and you can see that we actually received the event. Business partner changed for Alice. We blocked our own orders because we saw that we have orders in processing for Alice, and we emitted the event order blocked. And that's already the end of my demo. So I hope I could show you how easy it is, despite configuring all those systems, which is tedious and which I didn't show, but how when this is done, how easy it is to, first of all, get started in developing this kind of stuff, because you actually don't need any external systems. How easy it is to program it, because you can use the same query language to talk to external systems. And that the same coding also works when you actually connect to the real system in the end. So I'm not sure time-wise if I'm too early or too late.
Perfect timing, Daniel.
Perfect time.
And an absolute amazing demonstration of the power of events and messaging-based systems. And I'm just flashed by your coding skills, and you're doing all on top of that. I would need 3 times the time you needed. Excellent job.
Yeah,
and we have some questions in the queue.
Yeah.
One would be directly from my side. Is there a way to get rid of this mocked part, so that your the exposure when you start up your service only shows then your redefined part?
Yes, you can do that. I can show that real quick. So let's say you don't have this section here and you don't have this section here. Now, if you would run CDS watch, it would be mocked.
Mm-hmm.
But you can just run CDS run in memory, and then it's not mocked.
Okay.
So the manual command would be with mocks, so you can enable and disable it. So with mocks, would mock it. CDS watch does this automatically. Yeah.
Okay, and when I do then a normal CDS1, it will not show me some mocking part.
Yes.
Okay, excellent. Good. Next one is also from my side. I'm mainly using for getting my sample data in using the program approach by programming, which is shown also in the Kappa documentation. And here I have always issues when I copy data which contains date fields.
But this is files, you mean, or in the programming approach?
In the programming approach.
Okay.
When I simply copy, I have the output like the date field, date format is then the some date format. I think I will just simply file an issue on that, and perhaps we can make that easier.
Yeah, sure.
Good. And then there was one question regarding there was how the topic name is known from the S4HANA. I've answered that with the link to the api.sap.com. There is the business events are documented there.
Yeah, maybe a few words to this, because that's actually quite interesting. So when you use enterprise messaging on SAP Cloud Platform, it's very restrictive regarding the topics. So you only have a certain namespace where those topics are allowed, and so on and so forth. And here at CAP, we want to make it as easy as possible. You could, for example, see the topic I emit is just order blocked. The actual topic will be a little bit more complicated, because it will be prefixed with the namespace of the enterprise messaging instance. It will be prefixed with a service which emits this event, so it's kind of unique, or at least more unique than just order blocked, and stuff like that. So that also that happens under the hood. You don't really notice it, but it's good to know that it happens. So if you want to actually listen to this order blocked event, you can either use CAP, and then you can also write this.on order blocked, and the message would come. If you're not using CAP, you would need to actually write the full-fledged topic name, which is kind of generated.
Yeah. So CAP also lifts here the hard work behind the scenes.
Yeah, definitely. Yes.
Excellent. Good. And then there was a topic, it's quite long and also discussed. There was a question, I posted also in the chat, because perhaps it's easier for you to go on that. It's in regards to the CAP on Java. So perhaps I post the full thread here, because then it might be easier to get all the content. Yeah, it's quite long. So we're back and forth. Maybe that is something to follow up in the forums. Perhaps just post the question there. I think David is monitoring that closely. And
yeah, so this is correct. The rec.query that contains already the filters, the top, and so on. And I can just execute it on this external service, and all this will be translated in the proper HTTP call in the end. And yes, you can also change the query. You can add additional filters. You can change the top skip and stuff like that, or some filtering. And then they do something in Java. Okay, but it didn't do that. So I'm not sure how Java handles it, actually. So I'm then in the Node.js team.
Yeah. In the Java session later on, because there we have also the topic of rewriting queries.
Yeah. Excellent. And I think then we are quite through the topics. There was one question regarding the enterprise messaging that is licensed in the SAP Cloud Platform.
Yes.
And, so, and I think it's quite affordable. It's 1 million messages for some euros. So I think that is really okay.
Yeah, cheaper than a HANA. database.
Yeah, of course. Good. And yeah, I think we made it through it. Thank you again very, very much for this amazing coding session with, was it 2 slides? Yeah, 1 intro and 1 of the architecture. And so we will continue in the stream on 12:15. So in 15 minutes, take your bio break now and see you again there. And David, thanks again for this great show.